I recently did a video where I discussed whether the NVIDIA's DGX Spark is worth it, and the conclusion is that for AI developers and niche use cases, sure. But what about 3 DGX Sparks? For 99% of people, no way. But this video is going to be a bit different. I'll be testing this AI cluster not as a home labber, not as a YouTuber, but as an application support and development supervisor for a Fortune 500 company. Yeah, I have a real job, and I think this will be a fun perspective to see not only if the hardware itself is useful for my team, but how something like this compares to how large companies approach AI adoption and infrastructure in general. So yeah, let's just get into it. I'll provide you some context here so you understand where I'm coming from. I work for a large utility company in the United States, specifically in IT doing application support and development. My group has been around for a long time building and supporting software that's in use by our operations teams all over the country. 100% of everything we do is on-prem, so no cloud deployments, and we are a Microsoft shop, so most of it is in .NET hosted in IaaS. And some of the stuff we've inherited as legacy apps are written in C++ or VB. Anyway, what I'm getting at is that we aren't the most modern or sexy software development team around. But here's the thing, our company does have a cloud team and as of very recently, an AI team.
Wow, Brett, that must be great. Welcome to the 21st century.
Well, kind of. You see, as a large company with a massive IT department, a lot of our work is siloed. This means that while my team is in the trenches dealing with older tech and deploying it on-prem, our cloud team has access to their own AWS instance with the purpose of deploying new projects to a more modern infrastructure. Which makes sense. I mean, why wouldn't you want that? And our AI team, well, they just seem to get whatever they want. New MacBooks for daily work, dedicated AI laptops for projects, AWS Bedrock access with a seemingly unlimited budget, and free reign to build whatever they want. So I think you see where I'm going with this. Old man yells at clouds. Well, our company has an initiative to use AI to increase productivity, especially in IT, which is fine and all, but to fully leverage AI, especially for production level deployments, you need a significant budget. And do you know how hard that is to get for the boring legacy software team? I'll give you a hint. It's not easy. Now let's tie this all back into the DGX Sparks. I'm personally developing a RAG application to help my team manage our 100 plus applications via various code bases, different levels of documentation, and thousands of ServiceNow tickets, and the notes from each from the SMEs. And trust me, I know the meme about throwing all your docs in a vector database and claiming you built a RAG pipeline, but this is designed specifically for our group with actual usable outputs. For reasons beyond my control, I can't show you the full application, but I can show you some snippets. It's pretty cool. Now to build this, you need AI, but for my team to get access to AI, we need money. But to get money, you need to show a proof of concept. But to have a proof of concept, you need to build something. Through the power of Micro Center, I got my hands on a DGX Spark a few months ago that I've been using to develop this application, mostly in my personal time, and it's been perfect for that. I have 128 gigabytes of VRAM, which lets me load in plenty of smaller models to test with. After a while, I had a decent proof of concept to show off, which got some pretty positive reviews. And during this time, I was fighting to get my team access to an internal AWS account that I could use to leverage Bedrock. Fortunately, I was granted access and could link my app to our company's Bedrock instance hosted in the GovCloud. Happy ending, right? Here's the thing. I fought to get us access to these tools, but my budget is still razor thin, meaning that every time I test this or use any tokens, I need to justify it and possibly reason why other projects may not be funded. In the corporate world, that can be a big deal. So rather than worry about token budget, I wanted to deploy our own local AI instance that would have no strings attached and would let us use more tokens than 10-year-old me at Chuck E. Cheese. And I know what you guys are thinking.
Brett, that's $15,000 worth of hardware.
Yes, it is, but let me tell you something. It's so much easier to get approval for a one-time purchase of $15,000 than it is to rely on an ever-changing token cost subscription, especially since you then have to track and justify usage. Now, if you made it through all this, then let's finally talk about the performance here and my justifications. With 3 Sparks, that's a total of 384 gigabytes of VRAM, large enough to run some serious models, and not only that, we have enough horsepower to handle tons of concurrent sessions. This is actually super useful because in my proof of concept, I need to show that my app can handle a large number of simultaneous users since it is a user application that could be deployed to more groups than just mine. Well, if we serve up a smaller model like Qwen 3.54b, full version, we can get around 280 tokens per second with 16 users. And that's just one node. If you triple that, you're getting 17.5 tokens per second for 48 users if they're all hitting it at the exact same time. Now, okay, 17.5 tokens per second doesn't sound like a ton, but that's still very usable. And again, that's 48 people all running this app at the same time. I'll show some numbers from some other models here, so pause the video if you want to check it out, but the raw performance wasn't really the scope of this video, and here's why. The DGX Spark isn't something you're going to deploy your production level application on at your big corporate company, speaking from experience. It's a development machine, and this is the perfect use case to be able to show a proof of concept not only for how your application works, but how the infrastructure can scale using the same underlying technology like VLLM and a load balancer. Running a simple Nginx or F5 load balancer in round robin to 3, 4, 10 of these nodes would give you an insane amount of concurrent usage. Another benefit is that you can track the tokens used during tests without incurring any costs. I can have my team use this for a month, then let them go wild and come back to show what that would have cost using a standard cloud service, all for free. Again, stuff like this is so beneficial for corporate IT where innovation can often be stifled by budgetary constraints and red tape. And you know how this always goes, right? New technology comes out and it's great and affordable, everyone becomes reliant on it, then the company says, oh, we have to raise the price by a lot. Then you're stuck writing fat paychecks. Now, there is another cool use case for these Sparks, and that is their ability to use Tensor Parallelism, which lets you run a large model that wouldn't fit on a single node spread out across multiple ones. This is done so with the help of the NVIDIA Collective Communication Library, or NCCL, and RDMA across the 200 gig network ports. But why is this useful for my team, though? Well, for similar reasons as before, it's been a struggle to get access to GitHub Copilot, which is our coding assistant of choice, due to its native integration in Visual Studio. I'm not going to go into the details because that's a long story. Anyway, with 3 Sparks, I can run something like Minimax 2.7 AWQ 4-bit, which while quantized is still a 235 billion parameter model taking up around 110 gigabytes of space. And yes, the Spark has 128 gigabytes, but when you factor KV cache and system usage, you're not going to get that running. But on 2 nodes, definitely. Across 2 Sparks, a single user can run that model and get 41 tokens per second. And during concurrency tests, I got 60 tokens per second with 4 simultaneous users. That puts you right at that 20 tokens per second that I feel is comfortable enough to reliably use. And I did use it. I tested it with both OpenCode and a plugin that lets you run OpenAI models via the GitHub Copilot UI. Now, I'm not going to pretend it was just as good as Claude Sonnet and certainly not Opus level, but it's still very usable and again, very free. One thing to note is that I learned Tensor Parallelism for the most part only works in node counts that are a factor of 2. So 2, 4, 8, 16, which means if I get just one more Spark, I can cook with some real big boy models. NVIDIA? I already got the switch on the way. Now, another use case for this cluster is for my N8N instance. And I'd seen people talk about N8N, but never really tried it. And boy, this slaps. It's a workflow generator that lets you tie into a bunch of your applications, data sources, and other services, then feed that into AI to get desired outputs and trigger subagents. It's super slick. Now, before we talked about concurrent users, but in this use case, we're talking about concurrent agents. Imagine your team has a few workflows running, each hitting the same local model. You're going to want to make sure your setup isn't bogged down by that. And with VLLM on the Spark cluster, we get some pretty solid concurrency scaling. So there are so many different ways to use this hardware, and I've barely scratched the surface. I'll briefly touch on everybody's personal favorite AI assistant these days, Openclaw. Well, I'm not running Openclaw. I'm running Hermes, and I'm not really running it for work yet. I'm still testing it personally, and so far, I kind of like it. I think the idea when/if I use this for work is to have different profiles set up for each employee in my group and have them interact with it via Teams or maybe Open Web UI, we'll see. As for power usage, that isn't really a factor that gets brought up in our world, so that really wasn't too important for this use case, but I know y'all want to know. Each Spark used between 70 and 80 watts under full load, which gives us a total between 200 to 250 total watts. I will say I wish they were a bit more power efficient at idle because they're still sucking around 20 to 30 watts, so if you're worried about power usage, they're okay, but they could be a little bit better. So let's wrap this up because as I'm typing this script, I even know this is getting to be a bit too much. Is a DGX Spark cluster for everybody? No. That should be obvious, but I wanted to show that it does have actual use cases out there and show you an example of one. The biggest takeaway here is that they are relatively cheap for a large company to invest in for development purposes. It's just going to come down to if or how you can justify it. It's pretty convenient that it's the same basic technology of going from a 3-node DGX Spark cluster to investing in a few $100,000 AI servers. Now, obviously, way more cost and way better performance and a bit more complexity, but I'll tell you what though, if I'm a business that's looking to spend $1 million on AI servers, I wouldn't think twice about throwing $15,000 at a development/proof of concept setup. One thing I didn't touch on in this video is model training, and that's because I'm still working on that. The plan is to replace the generic Qwen 3 model with one trained specifically on knowledge about my group to further improve the RAG app and possibly use it for N8N as well. Then, like I mentioned, possible Hermes integration. So many things to try. And I know this video is super different from what I normally do. I know y'all came here for pool cleaning robot videos, but I wanted to try something new. If you liked it, then please let me know because I wouldn't mind sharing a bit more of this side of things. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my 16-node DGX Spark cluster with full Tensor parallelism running all the AI models. You guys are great. And if you're still watching, you're Olama. Thank you so much, and I'll see you in the next one.